Welcome everyone to our session from vision to reality, building generative AI. My name is Hassan Sherwani. Something about me, I hold a PhD degree in data science. In industry, I have around 14 years of experience now. And from experience, I have seen a lot of models working in academia, and it's really fascinating to see what research could do to economy and to market, but how would actually transition into reality, that is to our life. So how could we create value in our society using generative AI is actually something that is fascinating for me. And let me set agenda for this session. First of all, I would talk about Royal Cyber. I hope you all know about Royal Cyber, but if not, don't worry. We will give some minute to talk about Royal Cyber. Then we'll discuss generative AI. What is this about? What is this all hype and fuss? Is it worth actually spending this much time about this concept? And why industries should actually bother? What does it mean for enterprise? And maybe we could also get your experiences, and you can also share your experiences. How do you use generative AI, or maybe plan to use generative AI in your future? Then we have a couple of case studies, but one that we have chosen is ProClaim that we have recently worked with our client. And it's a very interesting case because we have been working on this project for more than 3 years now, and the way it started was a very different project of our data analytics project, and now moved towards high level generative AI solution. And finally, we would see a demo and some of future aspects of generative AI and our solution. And at the end, I would say that Q&A are open for like at the end, because now I'm presenting. Had I been taking this one live, I would take them right away. But now it would be very tough for me to, read back and forth. But if there is any interesting question, any comment, I don't mind that. Please stop me and share your experience, ask that question, and I love to answer that. So starting off about Royal Cyber, we are a company around 20 years plus old, around 2,000 employees around the globe. We have our head office in USA, Naperville, Chicago region. I work from Canada, so we have surprise, one office in Canada as well. We have presence in Mexico. In Europe, we have one office in UK, and we are expanding also to possibly in coming months to Netherlands. In Middle East, we have an office. We have our presence in India, Pakistan, and even if you go down there to the end of the globe, which is Australia and New Zealand, we have our presence over there. With this presence, number one, we can actually capitalize clients and our key resources around the globe with their different cultural diversity and edge towards technology. In terms of our partners, you can see we have been working. We are gold partners with Microsoft, partnership with Snowflake, Databricks, SAP. All these key companies are our partners, and we are really proud to have such technologies working with us and shown their trust upon us. Moving forward about data science, or so to say data analytics solution, we have actually four streams in this domain, which would come actually under my practice. So let me introduce you to all of them. Number one is data engineering solution. Where data engineering solution comes in is actually when you work with your business processes, their automation, data strategy, data modernization, data warehouse and ETL pipelines, and then maybe creating your intelligence reports and advanced analytics. All of these aspects or key features would come in data engineering solutions. Mostly that's like a first window of a project, because that is a starting point. Understanding the data, make some kind of an analytics, and make some judgment. But the next stage is machine learning solution. That's where you actually do some sort of forecasting or predictions to look at something in the future. And over there, the main task is that we work with our data, we clean that data, we process data, which is called pre-processing before our data could be served to the model. And then, of course, model building, model selection, hyperparameter tuning of model, and creating then endpoint serving so that it would be deployed. And over there, we can take care of other solutions. But That is something another domain. Coming to generative AI. Now, generative AI is an interesting case because it is a very specialized domain of actually machine learning, and I would talk about it later. But over here, our data size is incredibly massive. So we might be working mostly with the unstructured data, such as text, images, media files, and or even semi-structured data like JSON files. And then out of that data, we could actually find some kind of an information and generate our models. So some classic examples are like text, images, music data, code, and something like this. Final is MLOps solution. So what we do in this is that once our model is completed, we have tested our model, we have validated our model, and we have brought that into production. What happens that? So we have a joke at Cornell University that nobody knows what happens after you die, and nobody knows what happens after model is deployed. Well, I don't know about that, but I for sure know about a model, and that is that there are a couple of things. So it's not like a software solution that you have implemented it once and then you will just wait and watch and just observe it. No, it would change because new data points would come up. With these new data points, there might be different new patterns. Your model might actually start deteriorating. And if you don't pay attention to that, soon and very soon, your results would not be acceptable to your business team. So what you need to do is very careful. You need to check your model's performance. You need to check your data's performance. You need to check your data and model's quality. All these aspects are there. You might have heard about data drift, about model drift, about concept drift. Well, these concepts actually come under this MLOps solution. Now, earlier these days, all these practices or all these solutions were very, very different and they had like a complete different domain. But if you look at one project, now they all pieces actually get together and combine and formulate into one. So the project that we are doing, for example, all those components are part of it. And we have to hire actually someone who could take care of that more as a full stack, and then also someone who would be specialized into it. And I think eventually all of these would become one part of it as these domains are coming very close to each other. But our focus is actually on generative AI. And generative AI or AI in general is there for years. We all know that. We all have used Google, right? Yahoo in its heydays, search engine, and then we had some e-commerce tools or mobile apps where we want to find our favorite product or some recommendation systems from Netflix or Amazon. And then definitely, who can forget about Siri and Alexa? Always with some trigger words, and autonomous vehicles as well, which are right now moving forward every day with new technologies and new things. So all these technologies are there for some time, but why all of a sudden we need to create new words and new jargons, which is generative AI? So does it matter? And I would say yes. Actually, generative AI is a specialized type of artificial intelligence where you actually get some kind of a knowledge from an existing content. So through this process, you not only get some kind of a statistical model, but on top of it, you can write your own prompts to get your system better. So an ideal case is that whenever there is something wrong, you would either go back to your features to improve your and do your feature engineering, or you work with your model to use hyperparameter tuning. But there is this new technique, which is prompting. With that, it's a very smart way of solving the problem. With few prompts, you actually can create a better result for your model. It's just like an open book test for a student. So you just give relevant prompts, a human would do it. And prompt engineering, we all know, is becoming a new domain out of it. So definitely, there is a lot of substance for claiming this new term. It's not a hype, it's actually a new term. Looking at how it goes about. So if I would say that AI is something that is on top of everything. We knew that back in 60s. We have been creating models to play chess, and just beating humans is not a new stuff. So AI is there. But on top of it, somewhere in 80s, we started getting machine learning, and afterwards become deep learning. So deep learning is when you start working with neural networks and transformers and high level models. And on top of it, like there is a small tip, which is generative AI. And this is a very, again, as I said, it's a nuanced and specialized class. And I would talk about it more in detail about different components of it. But first, let me talk about few streams of generative AI, few applications, if I may say. Number one is text generation. In this case, we all know this. We all have heard about ChatGTP, and my cat actually get this as a trigger word. She could get triggered whenever she would hear about ChatGTP and start behaving in a nice way because she thinks that I'm talking to a business team. But jokes apart, we all know that it generates human-like text. Afterwards, we have image generation. It generates realistic images, such as Stable Diffusion. It's an open source model. In terms of audio, it generates realistic audio images. So there are two ways. Number one is that you use your speech recognition models. Another is that first you transcribe all of your speech into text data, and on top of it, then you use your machine learning solution. Most common or famous model is Whisper, which is being implemented. Finally, video generation. Now, it's very difficult to generate realistic video, and we all know why. We have been working on such projects where, for example, it gives you a scenario that if you are walking your dog and an old man would come from the other side, how old man would react or how your dog would react. So there could be like zillions of scenarios. So how would your model could generate that information if you are editing your video? What are the best solutions for predicting those solutions? So that's somewhat challenging. One way is that you just break down all frames of your image and find and depixelate them, use convolutional neural network, and on top of it, you use your Imagine video model. But that's just one way. There are many other ways. I'll talk about them as well. So first, let's talk about text generation. It's a very simple mechanism. We use actually transformer models. We all know GPT or ChatGPT next versions. But before them, there was simple GPT and BERT models, which actually started this revolution. The idea is that data set would be of a large corpus. It would based on grammar, context, and semantic understanding. Some use cases are content creation, chatbots, code generation, customer support, and even personalized marketing, especially we use recommendation system. Some famous models that we often hear about is OpenAI GPT-4, Llama 2, Google Bard, Falcon is there. List is like unbelievably unlimited. Next one is image generation. Now in image generation, actually we use, as I was talking about, either convolutional neural network or we use generative adversarial networks, which are called GANs. And I would talk about their functioning in a bit. But some use cases are art design, product branding, marketing, diverse content generation. Mid Journey is right now very popular. We know DALI, and I also gave examples of Stable Diffusion. In audio, it's interesting because WaveGAN analyze and mimic audio wavelength. So it's really speech recognition, like ASR kind of a model. When you look at text-to-speech models like Tectoron 2, then they are using a very different technology. So what they are doing is that they first change your voice into your text data. The only side effect could be that you might lose some human interaction, like your sentiments, like tone of your message. Those things might be lost in translation. But still, models are pretty accurate, results are there, and quality is pretty accurate actually. For music composition, it is used for creating unique jingles and creating different audio and voice files, and for, of course, customer care support, which is very, very famous. And we are seeing that over and over, even in our use case, we would see some examples of that. Meta's voice box and OpenAI's Whisper are leading models that are so far being used and provided best of the results. Finally, video generation. Video generation actually tackles this complexity of data from timestamp. So for example, you are on a T0 point up till this T nth point, and then you divide your data into different frames and then your model generate results. It's very interesting because it's not only that you would generate result from video to video, you can actually go across different domains. So one use case is, of course, video ads, films and animation, marketing content, and personalized message. Imagine video from Google, make a video from Meta, and Cog Video are most used solutions. Of course, there are other off-the-shelf models which you could use and find better solution. It really depends on your data, though. To my experience, normal case studies such as banking, insurance, retail, e-commerce, these three models are providing better results than other ones. But I'm still open to have ideas and comments from audience. If you have worked with other models, please feel free to share with us. Now we go a little deeper into types of generative AI, especially based on the data. So for example, if your input data is your image and your output is coming as a text, like image captioning, visual question answering, or image ones. Another issue is that you might actually have an input image and your output is an image, like super resolution or image completion. In an e-commerce case, we see these sort of cases. Another case is image to your video. That is where animation, the example that I was giving, that frame by frame, we kind of resolve an issue. Coming from text, if your image is text and your output is text, then it will be translation, summarization, question answering, grammar correction, like Grammarly use. In image side, we have image generation or video generation. So you just give your some input that, hey, show me key paintings of Leonardo da Vinci, and your model would show you actually images of those paintings. Or sort of say you are a customer on an e-commerce site and you want to see, you just write your caption and in return, you will get those images. Same thing about these text-to-speech models. You might want to transcribe your calls and you might want to just know what is happening in the call. So you just write a query that what happened at that timestamp and it would tell you. Or you can simply take a summarization from your speech as well. And finally, there is an output of decision when you play games. We have been doing this actually for input is a text and then output is kind of a game player or a simulation. So chess or ping pong and other games are there already that AI would play with you. So these are some of the cases. And let me now talk about how generative AI works. So as I said that initially or in initial round, we could go back and trace actually AI from Alan Turing time, since he started working and experimenting with the capability of machines and their learning and their reasoning. But I won't go that far. I would go from 60s and 70s when we started predicting decent models, mainly starting from weather forecasting and trading forecasting, something like these. And at this case, actually, we use two cases. One is discriminative modeling and one is generative modeling. So by discriminative modeling, I mean classical machine learning model. If you have a labeled data, you label that data, and then you try to find out different classes of it. So for example, if that email is spam or not spam, you will label all of your data points. You will train your 80% of data, test it on rest of 20% data, and then deploy your model. Simple as that. In your generative cases, it would be slightly different because you cannot label all of the data. So you would use unsupervised learning approach, and then you will validate it either via human or using some other methods that you can, of course, use. Second approach that started actually from 2014 is GANs. Now, GANs is something that use actually two neural networks, and one is a generator and other is a discriminator. So idea is very simple, that generator would create an output, a solution, suppose a picture or a painting, like Van Gogh's famous painting. And an output would be its discriminator. That would be like original painting. And as far as you will make these comparisons, you will teach your model to get as close as possible to real painting or to your desired outcome. And you will keep it, make it learn, 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 learn. So it's just like an example of a chef and a judge. The judge would give a feedback and chef would improve, the dish or the ingredients unless and until it would reach to the point where it's acceptable. So these are somewhat GANs. They use at the back of its reinforcement learning a lot. So if you would like to understand more, I can take a Q&A session and would explain this more. But interesting thing happened at this third point from 2017 when we actually started working with transformers, and that's where things start getting really, really interesting because it started from a very simple encoder and decoder model. So what we had is on one side we had encoders posed in one language in French, and there was in between them there was a context vector which would actually store all that information, so to say. And on right hand side we had a decoder, so from French to English, it would decode. Now, an interesting part is that in this case, you have a sequence. So for example, if I would say, Je m'appelle Hassan, and it would convert that into my name is Hassan. And you might know that there are different words. So Je m'appelle Hassan. So I have given this example actually last time with a community in Germany. They didn't know French much, so I could get away with that. Now I'm speaking that in Canada. So excuse my accent and my vocabulary, but the sequence is very different in French than in English. And sometimes words are different. So on encoder side, there are 7 words, and on decoder side, there could be 10 words. So this could happen. Now, how would model understand these parts? If on one sequence you have only 7 words, it should actually, on a mathematical level, make one-to-one encoder decoder. 7 words on one side and 7 words should be on another side. But in language, we all know it won't happen like this. And language have their own complexities. So that's where, on a research level, transformers actually came into being. And from 2017, now this is the point, and you can see in 2018, Elmo happened, then BERT, then GPT-2, and afterwards we can see how exponential this development is. We are seeing now every new day, whether it's Gemini, whether it's Falcon, whether it's the Copilots coming from Microsoft, all this development is happening over there. And the good thing is that, for a good or a bad reason, I don't know, it depends on observer, that on vision side, we also are seeing a lot of development thanks to multi-model approach. So what multi-model approach is that now you can in one go actually take care of your text data, of your image data, of your video data. So all of these different models that used to be create like different solutions are now coming under one umbrella. So if you don't want to use or create your own customized solution, you can actually make one or take an off-shelf customized solution which would provide you all those outputs. But it's not that simple as I'm trying to allude that it would have more and more involvement. But the point to be appreciated is look at this evolution, and I don't know how much more models we would have now afterwards this point because there is an improvement. So it's really a time where we are living is a race of models. Now, moving forward, these are some of Gen AI case studies. And why I'm more interested into this? Because we have used actually some of those cases, actually all of those cases. So number one is energy domain. So if you are, for example, predicting your dynamic pricing of your grid, if you have a smart grid, of course, the load at different time of a day would vary. Under this weather, like today, it will be a very different dynamics than a day in June with the full sunshine. So because of that, machine learning models actually, by checking all those variation, could give you a very solid and concrete prediction. How would you be having actually your electricity consumption in 7 days? What does it mean for consumers? They would actually get good and positive outcomes, make right decisions for themselves. For government, it's good because they would know how much consumption and how much load would they have on their grids. In finances, we have fraud detection, we have market analysis, we have claim processing, and all through these solutions, they can also cross-sell and make their recommendation system. On entertainment side, it's music and sound generation, and we know that, like we all are aware with Netflix, we all are aware with all these streaming platforms, how they use recommendation system and other solutions. So this is something not very new, but nevertheless, these domains, which used to be like there 2 years ago are really transformed because of generative AI models. So there is new energy and new accuracy levels for these, which we have never seen in this day and age. Coming to healthcare, actually, this is a domain which is going really strong with this development, because now personalized medicine, which was a domain and which really required a hardcore domain knowledge, with efficient and fine-tuned model, they can assist for a prescribed model. Drug discovery is a very difficult domain for a human. They need to actually have 16 to 18 years of proper education, licensing to understand this, but having a model actually could provide you pretty good results. And same goes to medical imaging analysis. Well, analysis is there for some time, since we are trying to look at cancer images, whether it's benign or not. So these cases are there, but again, accuracy is significantly improved. Then we have manufacturing, supply chain optimization, design optimization. We can create now digital twins. So that is there. On automobile, now that automobile is somewhat connected to energy domain, because if we talk about electric vehicle, how much load they would create to grid, that's number one. Then battery life optimization. So that is a very expensive component of electric car. Not only you want to know how much time is remaining to your battery, that's not a very big deal. You can find through your information system or a simple app, but your battery life, how long it could go and how you could actually improve that. It's more like your own health application. So we can predict actually that, and it is giving a pretty good result. Now, some journal benefits for organizations. I think I have touched upon a lot of them. So, automated content production, improved customer experience, cost and time efficiency, task analysis, data analysis, personalization, and customization. So, all are there, but one big question would remain out there, which I think all of us would appreciate, whether we should jump into this hype and start investing in artificial intelligence, generative AI in general, or should we wait and see? Now, I have a couple of examples. In my lifetime, we have a company called Nokia from Finland, which was a leading company in mobile phone. They had all market stacks. They were leaders in the industry, and we all know what happened. They actually proposed and commanded on Symbian technology instead of multi-touch smartphone technology, and they missed a big opportunity. They later on collaborated with Microsoft, but it was already too late. Few years delay could actually make you like out of the game. Same thing we could see. Imagine what was happening with Microsoft 13 years ago, and look at it now, where Microsoft is here. So they changed actually their mindset from a knowledge-based organization instead of resource-based organization. So we have learned that if you have high resources, market shares, or a big amount of a data, that actually won't help you out. Idea is the key. So as they say that if you know your life and your aim and your motivation, you end up making the right decisions. Same things go with organizations. So one point that I get over and over is that should we actually jump into and start exploiting AI? My answer is that absolutely yes, because if you don't, you would be just sitting behind and some other organizations would take the lead. You might be a top organization today, but in next 5 years, there would be another organization. And over history, we have seen this multiple times. In my opinion, rather in my humble opinion, because I am not a business expert as such, 80 to 20% ratio is a pretty sweet spot. So if you have 80% for your exploitation and 20% for your exploration, so that you could see what is happening in the domain. And with this organization and a consulting company like Royal Cyber could actually be very handy, because we are not a very large size organization. We are open towards ideas, and we can help you out with these whole new ideas and in these situations. So you can test, you can validate your ideas. Does it make sense for you? Do you find customized solutions or not? So that's just my take on enterprise level. Moving on with our first case study, which is actually a ProClaim, and this is for an insurance. What is normally our life cycle for insurance cases if I'm a customer? First thing happens is that I get an unforeseen accident happens, and then I just first curse the day, and afterwards I just report it to my insurance company. On that other side, there would be a consultant who would actually hear my concern, lodge a complaint, and then a claim assessor would assess this damage, and finally, it would go to repair shop. So these are 1, 2, 3, 4, 5 steps. Classical steps used to happen in 60s, still happens now. So we haven't evolved much. But let's look into what happens inside that organization. So what happens is that first, a document or a case enters our system. Then we do check, we analyze what is this case about, we categorize it. Then we move it to a certain department. If it's a damage, if it's a complaint, if it's a feedback, it would go to a correct department. Then after that, it would go to a claim inspector who would assess this, and afterwards it would go to this point, our dashboard, where somebody would actually check and see how it goes about, and finally we make some final action. It goes back to the customer, right? In this process there could be back and forth loop. So for example, this guy would actually transfer it to the right person, but this person is actually in a very different department. So maybe it's a feedback, it's not a complaint. Maybe the language is bold, so this guy would understand and would move it forward there, and then it would again go back into the system. So there is back and forth as well a lot into this current system. Now what I'm saying is that if we use AI, it would not remove this first point and this last point, but it will reduce this friction between that system. So what we hear always about that AI is coming to take over your job, it's not going to do that. It is actually going to ease your life. And how? Let me give you a scenario. So for example, if you look at a customer side, over here we have a senior citizen, and this guy has no idea how the world has changed, and he hates telephones, mobile phones. I can relate with some to myself as well. I don't like mobile phones as such, but maybe not that much. And first thing is that this guy would not be able to write a complaint. So he would wish that he would make a phone call like normal old days, and that is there. So his requirement is different. The problem is that if there is this call system, then again, a customer service guy would make him wait for 20 or 30 minutes to just understand a very basic concept. Then move to a different department. They will start from again and again, then move to another department. So before this guy would extremely get tired, his first complaint would be lodged. So it's really, really frustrating. It's not helping anyone in the company or to this guy. Then there is this more like younger generation, I would call Gen Z, and they would say that, okay, what if I could use and save my time so that I could maybe use more time on Insta and make a video of that damage instead of just filling like whole application or calling someone and waiting for 1 hour. And then there is, of course, a housewife, and her concerns are completely different. She would like to give some time to her family, and because of this she would like to again reduce time and speed up this claim. So she has like no problem with writing those complaints, but they are awfully long, same information, and you have to write that again and again and again. So all of these have like very different problem, but now you can see that all these problems could be actually sorted out if all their different data types are, number one, sorted in a system, and two, we have a model system that could predict and kind of passing this whole system. What about organization? So in their case, we have Bob, and that's like my favorite generic name. So Bob does work in a business analytics team, and he wants to work something about his own domain, wants to create, his own innovative flair to the company. But for him, it's a really problematic stuff because he has to meticulously read a document, and it takes him hours and hours and hours. So if he would read 10 plus document, he's exhausted. If I start doing that job, then in the first time on the morning with a coffee, I might actually get fresh. But by 3 p.m., 4 p.m., I'm extremely tired. And that's where we all make mistakes as well. So that's not really innovative and also extremely boring for this person. Eventually, he would get burnout, and we see a lot of burnout in our in our modern age, so not a good solution. What about CEO of that company? That's Rebecca. And Rebecca actually kind of observes this in her organization. So Bob is not only one, there are others who are actually facing the same problem. So she would actually seek a solution that would help not only her company, but clients as well. So through that, they all sit through in a meeting room and discuss what are our problems. And they create kind of a mind map through which they came up that there are processing delays, inconsistent data type, manual processing, prone to human errors, lack of automation, and limited customer engagement. All of those problems were absolutely there. And then this company came to us to talk about it. And that's where our solution come into place. So monitor, we would just provide these claims and provided a best solution out of it. And you can see this screen, it's there. And this is our dashboard, by the way. In this dashboard, I will explain this further in our coming slides, but that's the idea. So moving forward about our solution, once this insurance organization came to us, that was not their initial problem. They were not delving with machine learning on generative AI problem. They had actually a very complicated data pipeline where they had structured, unstructured, and semi-structured data. They were all over the place. To combine that data, they were writing 30 different languages, and they didn't know how to combine that into one system. They were using Medallion architect, which was also not working for them. So we helped them developing their data engineering pipeline and creating their analytics dashboard. Next solution was machine learning, where they used a predictive model to analyze their claims, predicted their claims, and classify their documents. And the third solution, starting from the last year, was actually generative AI, where they could see that how they can actually combine all these data points to get these smart solutions in a quicker way. In terms of methodology, we used a best solution because we were working with prescriptive analysis, predictive analytics, and descriptive analytics. And actually, you can start it from descriptive to prescriptive because first is a dashboard, second is some sort of a prediction, and third is that our large language model would actually provide a prescription to that business analysis, what to do next. An idea is very simple that first you collect your data, you process data, you build a model, and then you evaluate your model. And there is a back and forth. There is a feedback loop, of course. If your model building is not good enough, then you will go back to your your processing pipeline. And similarly, if you are evaluating your model and it's not good, you might go back here or you might go back even there. And finally, you would just integrate this whole system into one unified solution. So that's the idea of our whole system. So our first solution was actually data engineering automation. Over here, you can see we have our loss ratio, we have our geographic or geospatial data, we have frequency of our data points, we have our claim investigation, we also have about different customers, how much of them are fraud, how much were their cases were cleared or not. So it's like a full analytics. You can see it every day, maybe after a week or a month. You know this drill. This is a very basic first level solution. In a second solution, we did much exploratory data analysis. So instead of using a raw sort of a data, we converted them into our variables, aka features. Now through those features, we understood what is our data distribution. We looked at different bar plots. We looked at our correlation heat map. We looked at a pie chart through which we knew how much is the distribution of our classes. Then we implemented a model. We evaluate our model. We initially looked at whether it's overfitting, underfitting, all sort of classical machine learning approach. And then we checked our feature importance. And finally, we created a dashboard where you would just simply write your queries and press a button, and here you go, boom. You get an output, a prediction price for the insurance claim. And that was our second stage, next layer. And in this case, we moved to finally to our generative AI solution, where we had all those claims there, but we created some additional features. So one is claim analyzer, one is our damage analyzer, and on top of it, we created a smart support. What are they? I would show you one by one. So number one is, I will just let me play this one. This is our recorded video. So what we are doing is that this is our basic dashboard. Over here, we are showing that how many customers are there, their claims, their progress, and their reports, and yeah, rejected claims, how many we get, and its percentage, how much is actually decreased or increased. Solution of claims, it's again auto, travel, medical, or health. And over here, we are showing total claims and its revenue that is generated for this organization, right? So that's like a simpler first solution. How we did that? Number one, we used our PDF document or maybe a text document, the way that document would come to us. So a client would write an application that would be saved as a document. Then we would use our Azure Intelligence System to label out that. On top of it, we would use OpenAI's model, and it would be actually carrying out into this whole Microsoft Azure stack system. This is how our application would work. Suppose we have Bob over there who is working on this ProClaim web application, analyze document, upload a document, then object stored, model would trigger, it would generate summarization with results, key details, that is name entity recognition, and finally that would actually go to our model. Coming to solution, over here we are using claim analyzer, and suppose we load our document over here so you can see this whole system. So we would load a file, and the system is loading a file. It's David Johnson. So here it's the main transcribed form. The content of this document is over there. You can see some information one by one. CC, this seems like an email. And then we would use analyze now. One note, this is not real data if you are concerned that we are using some client's data. This is a dummy data for sake of this demo only. So now here we are. We know that this is an email. This is the status. The summary, that the email is from David Johnson, and it's a request of insurer claim document on an updated time. And there is insurance claim number, which was submitted following a major surgical procedure and expressed concern over the delay in reimbursement. So this is summary, what this claim is all about. Afterwards is key data points. So name of that insurer, insurance company, claim number, location, demand amount, date of loss, and phone number and policy number. All of that information is over there. What happens is that if you want to know some specific information that you don't find over here, so we have created this sort of smart support system where you will write your own query. So now we are asking if David is a regular customer. And yes, David is a regular customer and he carries a bill of goods, right? So something that is not written over here, which we ask our customer system and it would provide you. So this is more of a customizable solution. If you want to know more about it, you can write down about this document and it will give you more and more information. So again, coming back to Bob, his life and his time is actually saved through this solution. Next solution is actually our claim analyzer. Over here, we have an audio call. We just transcribe it. As I mentioned, we are not using a formal ASR method. We, on top of it, use Whisper, and then we would use OpenAI solution. In whole, the system is pretty same that an audio analyzer would work before. We would upload an audio file in the system. Whisper would activate. It would again summarize the system. It would generate this key information, and then it would be rendered to our system. So if I may run the system. So this is our content of our whole audio content, more like a transcribed system. And we are analyzing this. So the beauty is that I don't need to actually go and check this whole call. I don't need to. I simply just upload this call and I know that this is a call transcript. What they discuss is that it's a conversation between a customer, that's the name and that's the reason, and that's why she's actually applying for a loan. name, phone number, and all that information. So if you want to know some other information that's not there, which is of a more let's say not quantitative approach, but of a qualitative approach, you can also ask that information in the customer call. So in this case, we would ask about the behavior of agent, and no, behavior was pretty fine. So even for quality check, you can use this system as well. Agent was polite. So we just double checked and confirmed. In our damage analyzer, we have actually image and video both. So we are using GPT version 4. So note in previous cases, we were using GPT 3.5 because from GPT 4, they actually started using this multi-model approach and we took advantage of that. Solution is pretty same as for application. It would again use summarization, damage analysis, and image caption by inspection. And let me play this demo for you. All right, so you can see this car location, it's weather, daytime and clear. And then we have this license plate that is somewhat difficult to read, but anyway, it does pretty well. Model and underneath from the image, airbag status, bonnet, bumper, front fender, frontal damage, pretty severe, and kind of a possible cause. So it's pretty much doing all. It's describing what happened, and if you want to know about some specific query again, you can use this customer support system, and you can write about number plate maybe. And yes, give some interesting information. So let me pause you and see that. So it looks like a hit and run case. So it's already a suspicious one. And of course, from here, somebody could actually inspect more. A human would come into the play, but not only this would provide a summary, but this would provide pretty good explanation just by uploading a simple image. Let's talk about video now. And video, we have like different frames. You can see it's different frame from different looks, the damage, and model will analyze all these image frames in one go. So it's urban street with graffitis, other vehicle, no other damaged vehicle, airbag deployment, no visible information about this. And you can see front end information is there, right side information is there, possible cause, high speed frontal collision, and then vehicle information. Color, its model, and it's Mercedes S-Class. by the way, nothing against Mercedes, so don't take me wrong. And daytime, dry road condition, no visible station. So seems like it's a fault of pretty much of a driver. So if the claim would come into place, it doesn't seem like that something could have been done. It's most likely the car is damaged from front and it's the driver's fault. So that's about this one. And then finally, we have our smart support system, which is using like a chatbot. We are using a retriever on top of it, which would fetch the information. Then it would give into our knowledge base. And then we used our large language model, which is primarily of OpenAI. We are using vector database as well since we need to store our embeddings, and we are using Pinecone for that purpose. Our architect is slightly different than the previous one because over here we are not using a model to generate something but to retrieve some sort of an information. So a chatbot architect is slightly different than other systems. Overall, this is loosely based application overview. That's how these different solutions work into one place. As I've mentioned, we are using 3.5 over here, and down there we are using GPT-4. Because of this, you can use either one. You can use GPT-4 by using multi-model approach. You can save some cost by using different versions or a previous versions, which would actually help you out providing better results. So it's really up to you in such cases, how you mismatch and develop the solution. Then we just define this architect over here. I have already gone through this, that it's not about just implementing one model. It's about looking at data source, its integrations, how you are implementing your structured or unstructured data. Then embeddings, which is a pre-processing system. We have Cohere, Hugging Face. In VectorDB, Pinecone, Chroma, Viviet are leading. We have used Pinecone. In our large language models, we have different models: OpenAI, Palm, Anthropic, Bard, Cohere, and finally apps, Streamlit, Mistral, and Modal. All of them are there. On orchestration layer, most famous is LangChain, but Llama Index is doing pretty much breakthrough as well. And a cloud provider, you can use AWS, Azure, or GCP. We are using Azure in our case, and our client is using the same. So what are next stages? We are in discussion for other verticals such as health, home loan, deposits, and travel insurances to get this information to our model. Challenge is that it might be much more tough for us to give this information to our model because context would vary. If there are two ways, either we fine tune our model or we provide a better RAG approach. That is, we augment more and more data with that. Second challenge that we are thinking about is using advancement in generative AI. As I have mentioned that we might use actually this multi-model generative AI approach with our insurance cases. Then we are also creating a fraud detection module explicitly because right now our machine learning models are just giving this information or prescribing that it might be a fraud, but we need to be really, really sure under what probability it is a fraud and what could be consequences of that fraud by looking at history of a customer. And finally, with something that not too many people talk about, regulatory compliances and ethical AI, but that is very important to take care of data privacy, to looking at integrity of customer data, and also creating a safe and best practices for our data governance shield. So that is another part that we are taking care of it. Not stating that it's not there already, but we need to use more advanced tools. Some of limitations for generative AI, because I have so far been pretty much pro Gen AI models, but number one is that they lack this worldly knowledge. Unlike humans, we of course know things, and from our domain, if you have someone who has educated themselves for 15 or 16 years, that might be the case that our model would not actually go and pass the same litmus test. Second is model biasness. It could happen that on certain data points, model would perform way better than others because those data points or those data histories are there in our system. If we would just like to remove that third shield, then our model would actually give some inappropriate or unsafe output. So for example, if we have a chatbot which would be talking directly to customers based on the corpus and the data that it is trained on, it might actually use some unsavory statements. And that could actually be bad for organization image. So unfortunately, we are not there yet where we have like a full trust on AI models because we cannot trust our data. Second is absence of a deep understanding. By deep understanding, I mean meaning of deep understanding. A classical example is that if we tell our machine learning model that a cat could not walk the street because it was too narrow, are we talking about it through the street or through the cat? As a human, we know what it refers to, but our model would not. And same thing goes when you are doing, for example, a chat with the bot, that you have written one query and the second query is related to the first query, but model might not actually understand. Machine learning has this concept called chain of thoughts, which is actually helping out, but we still have some way to go. Uh, yes, Anthony, do you have something to add?
Yeah, actually, I was going to ask you about some of these, in your flow that you used with Bob. I was just curious, how you accommodate some of these limitations, like the biases, the sometimes inappropriate outputs, and
Mm-hmm.
the inability to fact check. Because my experience is that all results have to be very closely scrutinized because generative AI is just such a good writer that it can write results that are so believable, but they base it on possibly unsound assumptions. So how do you accommodate for these in your user flows?
That's a secret. No, I would come to that. A true magician, as they say, never reveals. But I would, very shortly, I would just get to the point. So that's where actually I'm heading to that. That I have been in this presentation being really pro generative AI, and now I am becoming like devil's advocate and telling you these negative thoughts. So the idea was just to give you first to promote something, and then you just give you like, okay, just think about it, kind of thing.
Okay, you have a strategy here. There's a strategy working here
Yes, that's
then.
a that's a gotcha strategy. So coming back to this fact check, as you have said, it's extremely important to fact check. So what is happening actually right now in the world is that if I conclude this whole pitch of today's presentation in few lines, is that we are after 2017, when we worked on transformers, we really moved on to this model centric approach. We thought that if we would create new models, which we are, every day you would hear there is a new model, there is a Gemini, there is a new version of OpenAI, there is a new version coming from Model Garden, and all these things are happening right now. If we create a model, a universal best model that would be trained on millions or trillions of data points and with thousands of parameters, we would actually find a universal model that would solve all of our problems. And the point that Anthony, you have just mentioned is that how would we actually fact check? One example that I always give is that if your model is trained on extremely toxic and racist comments, your model would actually provide a very racist output. There is no way that it would do anything else. So how would you actually create a model that would provide with a toxic data would provide you a right result? It's just like that if you are born in a toxic family, how you could be a positive person. Well, there are methods, but the approach that actually Stanford school system came up is that look at your data and fix that point. If you have some kind of these anomaly behavior, maybe before putting it to your model, just think about it, what data you are feeding to your model. So one is that word cloud. So word cloud provides you that what kind of keywords or like the main words are in your system. And look at those words and give it a quick overview that is it something that I want to give it to my model? And if it is so, then my model would actually do the same thing. Another point is that instead of just going to the model, look at one step behind. Do pre-processing. Use some good techniques for your vectorization methods that are already there. Also, we have a combination where we have our tabular data combining with our image and unstructured data. So at the end of the day, these all are converted into numbers. I don't want to go really in a technical way, but just to give you an example that if I am writing my name is Hassan, machine will not understand these words. It would always convert into a matrix. So 0010, that would be my 0110 would be name, and so on and so forth. So it would create kind of a stream of matrices. It would be at the end of a day a number. On the other side, if I have, for example, my insurance forecasting, these are number 13.5 or 12.5 or 3. Now, my model should know that the 0 and 1, they are coded values. They are not comparable with a numerical number, because in that sense, model would think that 13 is greater than 0 and 13 is greater than 1. So it would start calculating the results in that way. So now you need to give your model a proper understanding. And that's where you would just go one step behind. You would go to your embedding, you would go to your feature understanding. And for this, you really need a very good data scientist who would work all through this system. So that is one way. So this model-centric and data-centric approach gives some kind of an interesting perspective, but I would profess one step further, and that is this platform-centric approach. And why I'm saying this, that because we are working with a system which is a full ecosystem, an end-to-end big solution, where you are not only implementing your model or not your data, but you are also implementing your model into production. Suppose I am showing you this ProClaim site and you write a query and it would take 10 minutes to get a response and it's extremely accurate. Would you buy that? Never. It's extremely frustrating. So speed, your latency, your consumption is very important. How your data is coming through different pipelines is very important. For this, we create different tools. We combine all different models. We combine all vectorization methods, all MLOps jargons, and all these data engineering tools together, and they all speak different languages. At the end of the day, you will have JSON images, you will have Parquet files, you will have different CSV files, and all of these files would speak different languages, and it would create a mess of a system. And every time you need to kind of fix one thing, you would actually get into a trouble. So a best approach is to use a platform-centric approach. Databricks is providing this smart approach, which they call this intelligence platform. Microsoft has Microsoft Fabric. And I have like no dog in this fight. I think both are providing pretty good results. But the point is that you have an end-to-end system where you are providing some sort of an outcome. Another another interesting development which is happening in this generative AI is copilots, which are very quick plug-in solutions which are connecting different solutions. So instead of, for example, having a full certified or licensed product of SAP or ServiceNow, you can create a copilot of your system which would kind of plug in with another system and could provide you a result. So all these developments are interesting, but at the end of the day, we need to consider an ecosystem approach where all those data files, all those data systems are there through which we can experiment, through which we could fix our data, through which we could actually fix our models. And to just answer your question, Anthony, that's just like one line that if we have a platform centric approach through which we have like a full understanding and full transparency, only then we can fix it. Because if we fix our model only, then our data would actually react in a different way, or we would get into innocuous our pipeline issues, which is not desirable.
Um, Hello, I have a follow-up question on that.
Yes.
So, but if the data itself, as you said, is coming in with bias, societies are embedded with their own bias. Depending on where you are, the data will have certain bias. So is there even a way to address that? I mean, if you collect data from Europe, you definitely have some specific European bias. You do this from Africa or the Middle East or the US. And if you put all this information together in one giant world kind of model, it
Mhm.
still would it still will come with its own geographical biases. So is there a solution to address this? If so, maybe you can elaborate.
Yes, there is a solution to this, and actually there is a plethora of research on that. So I won't be the first one to highlight these solutions. Number one is that most of the data that now we are using, English is becoming our common language. So even my home country is Pakistan, and I have a lot of colleagues from India. So we both speak a certain language, but even we have cultural differences, right? But we speak common language, which is English. Now in English, if you translate those emotions or those biases, they are very different than our own home language. So that is number one, biasness. One way is that if you have a system like you use RAG, which is retrieval augmented generation method, you provide certain prompts to your model. And through that, you can remove those biases if they are undesired, because not all biases are bad. Some biases are part of that culture and should be there. But if those biases are somewhat not socially acceptable, then of course you can tell your model not to use that or not to trust that data. You can always prioritize some form of a data over another form of a data. So whenever a word is generated or a sequence of word is generated, it would always give you a probability. So if I say that my name is, based on my previous history, model would say Anthony, Hassan, or maybe Shakespeare or something, Victor. So model would actually give me different probabilities. I need to choose which one is more suitable and culture appropriate. And then it would actually go forward. So it's only the game of probabilities that if you are concerned about biases, the number one solution is that improve your probabilities, provide a RAG solution. Another way is that if you have in-house data. So for example, if I have a banking data and I'm using our ProClaim solution, which is on insurance. Now I want to tweak it on banking data. I would fine tune my model so that it would know the key patterns of banking sector instead of knowing more of insurance sector. So it might know both sides, but maybe focusing more on banking side. So you can fine tune your model as well. So these are like couple of methods that you can actually implement. And of course, as I said, that there is no one unified or perfect solution. There is always R&D, there is a hit and trial, which we can do. And hopefully we just get better and better results. Make sense?
Thank you.
So with this, I would stop here. So you all have been very patient. Listening to me is not easy, I know, but it's your time now. Please go ahead. Comments, questions, concerns.
Sami has a question. Hi, Sami. You can unmute yourself and go ahead.
Yeah.
Hi, Hassan. It may not be technical, but just wanted to ask, for example, there are multiple domains where companies are spreaded, right? As a company, if I'm unaware how generative AI can help me solve, X, Y, or Z problem, can Royal Cyber help me with consulting and identifying the opportunities and later on implementing those cases for my company?
Yes, that's a very valid question. So actually, what happens is that we have first session about exploratory calls, and that
Mhm.
is mostly if you are coming from our event, it's actually complimentary. There is no fee. We try to
Mhm.
understand what your problem is, what domain you are. Since some clients are actually not solving hardcore generative AI problem, suppose they are solving an optimization problem, and they don't know that, and I don't blame them because they are not technical. So we help them out in understanding their problem, gauge them with the right tools and right setup, and help them out with a small POC. So that's like a step-by-step thing. And as I was saying that how enterprise should actually approach this problem is by testing. Before jumping and investing their millions of dollars into that, it's always a good idea to test that idea first and see their level, whether AI is something that they want to invest and move forward with. And Royal Cyber would actually help them out in this. We can create a POC. We can have like further sessions on a call. So yeah, that's to me that's like a perfect step to move forward.
Right. Thank you so much.
Session, that was a great session. Thank you so much for your time, and thank you everyone for joining this session too. Hopefully we'll see you around the next time as well.